And before I forget, okay, so where do I want to display lives left? In the original game, they used some space up here to display like the time, like a timestamp. I think that we can do the same thing here. Like there'll be our time left could be countered, and then we can also have like a lives left. If we do like time over here on the left, we could do lives remaining on the right. I'm thinking about doing exactly the same thing that we did in the Get the Streamer game, where we'll have hearts representing the player, and then that can be just sort of like just right here. I don't even think that I'm gonna need. Player gets 1 life on death. Delete the entire Raspberry Pi. Also, I just heard a crashing noise outside. I'll be right back. All right, no problems. Zilby, it's not our car. Zilby was trying to jump up onto a windowsill in the bathroom in order to get a good look out at the neighbor's yard and, you know, see all the snow and everything, and then just knocked over a bunch of stuff that we had. And then he ran into here and then immediately ran out also. So that was fun. Typical cats, exactly. Typical cats. All right, so for lives, we're gonna want some like image here. Okay, so let's go ahead and assign ourselves display lives on the screen and assign myself this. We're going to create a branch for it. For this, thinking a heart, like a heart logo and a heart image, in the top right, repeated for the number of lives. We can start with 3 lives, therefore 3 hearts. Well, we need a heart. So, oh, your cat is busy whispering meows at the birds outside. Our cat hasn't really gotten into bird watching yet. Although there's also not that many birds out. Like, do you have birds right now? Don't you also live in a place where it's snowing right now? Oh wow, you have 30 birds outside even though it's friggin' freezing. Okay, so let's open up a sprite. I want to do a brand new image. This can also be 16 by 16. Birds know that your feeders are the place to be. Nice. Okay, so we need to create a heart image for this. Now, if we choose something like nice and deep red, is there a way in Sprite to do like the mirroring so it does both them at the same time? Yes. How do I do that? So where's the controls for that? So frame properties, cell properties. Symmetry options. There you go. So perfect symmetry. So if I do something like, oh, that's gonna be interesting. I need this not, I can't go right in the center like this. 16 by 16 isn't the right size for that. How is this for a heart? This might not be deep enough. Delete the corner on the top. Let's see. Eraser mode. Are you talking about like delete the corner on the top? Like up here? Yeah, that okay. Yeah, I could see this. I mean, it's certainly good enough for right now. So I do this, save as heart. Did you save as an Sprite file? You did. Okay, perfect. Then I want to export the heart. We've learned that we need to resize you. Visible layers, all frames. I mean, there's no frame. There's just one frame. Okay, so export for Twitter is strange. Okay, so export. Here's our heart. I actually wonder if this is gonna be too big. Maybe I don't need to increase it by 1,000 times or 10,000 times or whatever when that number was. Anyways, let's go ahead and pull you in to our resources. Heart.png. Okay, so first of all, we need to load this into the images. We actually have like tests now for this that allow us to like test and make sure that the images are being loaded up properly. We're also pulling this from config. So it's really going to be our config.json first. So our heart image. And should this really be a heart image or a life image? I don't know. Maybe a life image. Right now, what am I doing? We're doing like player image. Let's do life image for that. So that way, if I choose to not make it a heart anymore, it's separated out from the content of the image for what I actually want it to represent. So this is a life image. Image, and you're going to be / heart.png. We should probably give it our heart. Like, do I need to give it the probably, like, to say what it is? I don't know. If I just start with that, life image is heart. Pull in. Let's see. You are just a string. Then we'll go to our images. And so from here we give it the new images. And we're gonna load this up separately ourselves. So let life image equals I could just do this. Image new context config dot life image wrap view, and then we're going to assert equal that the life image dot to RGB8 that you are the same as the images dot life. I guess this would just be life dot to RGBA8. And so this is the way I've been testing to make sure that the life image system, like the image system is working and actually pulling in images and storing them. So we can now store in life here. Life is an image. That life equals image new context reference to config dot life image and life. All right, okay, so that test is passing. We have the life image in the system. Do we have lives? I want to say that our config.json, we actually have the number of player lives in here somewhere. Is that true? No, we don't. Okay, so we're going to need player lives. We're going to start us off with 3 lives. Yeah, we'll just start us off with 3 lives like that. Which means we also need in here you are going to be a U8. Okay, so we have our player lives, we have our image, and now we want to draw the number of lives left. Well, okay, we need to track the number of lives that we have. So in our game, is it going to be our game object? Probably our game object. Because it's going to need to like have some kind of is alive. So that'd be here in game object. We could store lives left here. And then pass that in when we create a new one. And then that way, if we have like a rope swing, it just has a life. And there's no way for it to to lose a life. Now that's that way. Now in a previous game, we had a life system. That might be better. A life system might be better because not everything actually needs a life. So we probably want to store a life system in here, have it be an option. And then like the player, for example, gets a life. And pretty much nothing else ever does unless we add something in. So we can have a life system for the game object, and that would be none by default. So if we want to test a new game object, so game object now we can start sort of like converting very slowly over to a not exactly like a builder system, but like have a method that adds a life system. So inside of here, we could now assert equal that the game object dot life system is a none. I don't actually know if that works. So here we're gonna have a life system, here an option. We don't know what you store in it. I don't know if I can do absolutely nothing. No, I have to give it something to go in. So hold on, before I do this then, we have to create the life system. So we have to create a life system, and then we can start playing around with that. So let's here, let's clean up some of these, our workspace here. Okay, jungle, in source. We want to create a new folder. We're going to call this life systems. So the main library. All right, so for you, we're going to start with a trait for this life system, just in case we create other ones. So pub traits life system. And if I don't have anything, if we don't set anything up for it, we're just using this for the type right now. This then gives us the ability to then go back to game object. And now we can say, okay, assert equal that game object dot life system by default should be none. So we'll have a life system, and you're going to be an option box sign life system. And so when I create this, we'll have our life system be a box sum. Oh no, it's just a none. You're just a none. Now you, Binary operation cannot be applied to type. Standard box. Life system doesn't implement debug. Right, okay, so we need to do that. Now I think we can do that with a where. Where trait equals debug. Oh, where's the thing where we can do where? Because you can't derive on a trait, I don't think. It's where something debug. Oh man, I forgot what it was. We can go take a look at it in our previous code. So to get the streamer game, we did do this several times. So here, we'll just go take a look at this life system. Where self standard format debug. That's what we did. So where self debug, like that. Okay, so macros equal cannot be applied to type standard option life system. Does that allow you to use debug trait methods in this trait? I believe so. I believe so. Can be applied to type option. Do I have to do partial equal to? I guess I can't do this. Togglebit, you heading out? Oh no, Togglebit, you're here. Oh, sorry. Never mind. I got mixed up and confused. Togglebit, hello. How? It is going good. How are you doing? Let's see. Is an enum. Oh, can we do matches? So can we just do the assert? There's just a normal assert, right? Yeah, this one. All good. Oh, but a headache prevails. Oh no. I'm sorry to hear that. So can I do a matches? Game object dot life system and none. Do you work? I think it does. Yes. Okay, so that's how we can test that we have a none in there to begin with. Okay, excellent. So then we want to now just create our life system, and then we can add that in. So we're going to come back to our mod life system, and we're going to create a new file for player life system. All right, so pub struct player, and actually we can do test-driven development with this one. So what's that? We want to do. Oh, my auto thing isn't working. Okay, fine. Config test. Nobody can do TDD. It's a myth sped by the Illuminati. Well, I'm trying to join the Illuminati, so that's why I'm like working on this. like once I figure out this test-driven development thing, I'm sure that I'm going to get an invite in a mail or something. Oh, the Illuminati pay as well. Well, I mean, if they pay well and they have good benefits, I'm all in. All right. So you presume they pay in souls. I mean, if just life becomes a game of Dark Souls, no, that'd be terrible. Also, I just saw a bird outside, so I was like thinking that just reminded me like of the 30 birds that Danny has outside of his house in the snow. It doesn't look very happy though. It's like landed on a branch and it doesn't know what to do. But okay, so what was I doing? I just distracted myself massively. Okay, so we're creating a player life system. So let's try this. CI test create player life system. Let's try doing the builder method on this. So that way I don't need anything else. We can just do let player life system is equal to player life system new. Like that. So we start out. Obviously we have an error because of this. So this is like the test-driven development. We write the test, we get the error. Now we do pub struct player life system impl player life system. Okay, so that makes us happy there. Then we get this, and then we could partial equal this and do assert equal that player life system is equal to just a player life system like that. I don't know, like, what's even the point of that test? I don't know if there is. Doesn't feel right. Also, how did it get five errors? All right, so we would need to implement partial equal, I think. So derive partial equal. It's 3 errors. We need to implement debug. All right. Then that works. You write a test for a small behavior, which will force you to write the new, unless you're totally stumped. Then I go ahead and write the silly test. Yeah, like I don't know. I'm still trying to figure out like this thing. I tend to end up writing silly tests because like mainly because I'm doing the test to figure out what I want to do, and that sometimes ends up with silly tests like this. But it also helps me like think and about like what I want to do. It's like I might just delete this test and not need it, or turn it into something more useful. Okay, so if we create a player life system, well, we know we need the lives added into it, right? So I need to add lives in. So probably something is to change this, instead of create a player life system, to add lives to player life system. Your first test sometimes looks like test something, where I use the test title something because they don't know what to do yet. Then you filled in what I've done. Yeah, I do something like this where I like change them around as I go through. So it's very similar to that. Okay, so add lives to player life system. We're gonna create this new, we create a new player life system, and then we want to add a life to it. So we probably want to assert, then we make this mutable. Then we do, you find TDD without a spec scope is a bit tricky. I could see that. I often use TDD to like prevent myself from going too far off the deep end with scope creep. Because I have noticed that if I don't do TDD with that, then I just sort of like, ooh, let me add this thing, let me add this thing, let me add this thing, and then I just have nothing, no tests, and like partially created features, and nothing works, and I don't even know why. With TDD, at least, it forces me to say like, oh, I need the other thing first. Let me like change my order around, and then at least my tests make sure I don't do anything wrong. Yeah, scope creep for the win. Okay, so player life system. We want to now do player life system dot add. Now, if I do this as like a builder pattern, it won't be add new. So it would be something like create player life system with lives. So we do something like this. New dot lives, and then set it to something like 3. We'd expect the player life system to now be a player life system, and then we can do player life system dot lives is 3. But I don't think it's going to be quite as simple as this either. Wait, don't forget to delete it at the end. Oh, the 5-hour function. Like, take 5 hours to write one function and then delete that at the end because, like, well, I didn't really need this. We've done that a few times ourselves. That's been fun. My favorite thing to do is to, at the end of each feature, git commit and push that up. So that way, if I write like 5 hours of the code, I can just go in and just do git checkout -- dot and reset. Wait, my video game doesn't need a printer. I mean, are you sure? How do we know until we make one and then try it? So in this case, when I create a new one, our lives 3, so we're going to have to unwrap this first. So lives dot unwrap, because it's going to be an option. It's got to be an option, because if I'm doing the builder pattern and it's going to hold the lives, it's going to be a none until we have lives in it. Then it's like a 3 or so. So if I do this, first of all, okay, there we go. Player the new dot lives. So we need to have a public function lives that takes in lives, which is a U8, and is going to return self. Okay, so let's just return self like this. And that's not true. With a dot, this is going to take self in like this. We're going to take ownership of it and then return a new self back again. So we're going to return self. Now, then you're yelling at us because we don't have a lives in here. So let's go ahead and add in. We have lives. You have to be an option with a U8. So your lives and none. Okay, so we could run our test now and it should fail. I go run, I go test. Okay, you should fail because we called unwrap on a none value. Okay, So then to make this pass, we want to take in our lives. We'll do self.lives is equal to sum lives, and then return self. If you made a player life system builder that only let you build a finished player life system, you wouldn't need optional life. Oh, okay, that's big thinking there. Big brain thinking. I like that. Cool. You need to be a mute self. And so this works. I like that. My work is way more interesting than yours right now. Why is that? I mean, I know that like game type stuff is often interesting just because like the graphic element of games. Like you have things shooting across the screen, and I know you're making like a well, you're writing documentation. Yeah, I could see that. All right, did you save all the documentation for like one large giant slog, or are you doing oh, you mean real job, like your real life job? Oh God, yeah. Well, sorry about that. I've been trying to, at my real life job, do documentation at the end of every deployment instead of like putting it as a to-do list and then having like, well, we have like 18 tickets for documentation. Let's just spend a sprint writing documentation and then we'll hate ourselves for the rest of our lives. Let's try doing what we were suggesting for a builder system. So if we test creator player life system with lives, then we want a player life system builder new dot lives and then that will probably then like a dot build. Okay, so then this can be player life system. We don't have to have the with lives anymore. It'll be just create a player life system, new, give it lives, then build it. That will give us a player life systems. This will be a player life system, and then you will be player life system dot lives. Should be 3. All right, so bunch of problems here. Right, so our play life system, obviously you are now just a U8. We're not gonna have this anymore. In fact, we might not even need a new on here. You are secretly 2 monkeys in a trench coat, and this is the day you realized reading out chat messages aloud in stream is sometimes a trap. Ooh, I have not had that in a long time. So I've gotten out of the habit of like reading them before I read them, if that makes sense, which is not the best. Did they get you, or were you able to catch it before you finished reading? Found yourself reading out chat messages aloud, and today it really got you. Oh. Okay. Okay, that 8 is not a type. U8 is a type. Okay, so we're not implementing a player then. So, okay, now we need a player life system builder here. So we'll do a... I don't even know if I need this anymore. We now need to create a pub struct player life system builder we probably do need to have options inside of here. I've not actually looked at any of the building patterns, like how other libraries do this. So I'm sort of making this up as I go along. So here we're going to have lives as an option. U8. And here we're going to import player life system builder. Pub function new. We return a self, and this will be a self lives none. Okay, then we're going to have lives. Oh, you're done for? There was a clip and everything. Oh no. Going to go from Java memory, but your builder would be options because all the values won't be there until you do the build. That makes sense. And then we can have like a validate function that'll validate that it works correctly. I need to return a result or option from the build. Yeah, that, okay. Oh yeah, that's a really good idea because we're going to have to unwrap this. And then that should give us our lives. Okay, so we have new. That gives us that. Pub function lives. That takes in mutable self and lives, which is a U8. Turns self. And we're going to do self dot lives. Comes a sum lives. Then we return self. Now we need build. So, okay, depending upon how you do it, you won't need to return an option. I'm probably not going to return an option. I'm going to return a result. I think I'm going to do what Peyton is suggesting. Return a result. If lives are necessary, you could do player lives 123 that returns the builder. Yeah, like I sort of feel like it's a little bit, we're doing like, this is not necessarily the best thing here, but I'm sort of like also learning this pattern, which I could probably use for, more complex things later. But it'll also make testing things a little bit easier. Now, if we have build, that means we're gonna have a validate. But let's start with, we just build this, and in this case, it's gonna work. So pub function build. In this case, we take in just self, and that's it. And here we're going to take in a player life system. Or no, we're going to return a player life system. No, we're going to return a result player life system. Wait, result needs an error too. How do I create my own error type? I've always just used static strings. Yeah, I'm going to do the validation inside a build. I don't know if I'm going to do like a validate out like another function that build calls maybe, but I'm going to do the validation inside of build here. If you need lives, you can let the type system handle it for you, so you can't build it without types. I know, like, I don't really need a builder. Like, I don't need a builder system. I could definitely build it just like from here with lives. I mean, because like if I wanted to just do this in the most efficient, like best way possible, I don't need the builder. We just do lives, and we just have like a new. It takes in the lives, and that's it. And like maybe we should do that. Maybe we should just do no builder at all. I don't know how many parameters I'm gonna do. We could also start with just a create a player life system. Player life system equals. Let's do this. Player life system new 3. Like that. And then rid of view. Import player life system. Function new. Builder could use sensible defaults for the player life system, in which case your build function would always return a player life system. Yeah, that's true too. For right now, because like the config is gonna control all of this, I don't know if I need like the config is gonna be what everything has. Also, hello, Jeff Erroneous. I like to use the builder pattern with sane defaults. That also eliminates the need for options. Ooh, that's nice too. Okay, so if we have new, we're going to take in lives, which is a U8. Turn a self. Okay, so we do that, and then you'll be happy here. So don't need to be mutable. We hand you that. Now, because I'm controlling this all through a configuration file, and the configuration needs to have these things in it so I can control it, it's a kind of a moot point for us. But all right. So, given... Okay, so we can now create a new life system. We know that it has lives. We can now pass this player life system into the player game object. And, oh no, we can't yet, because we have to implement impl life system for player life system. And there's nothing for it to do yet. We need you to implement debug. All right, so we're happy here so far. In our game, let's see, in our main, so here you have our life system with an option. I have not explored the type state pattern. At least I don't think I have. I mean, maybe I have and I just didn't know that I was. Like maybe I didn't know the name of it and I was just sort of exploring it through some other things. But I would say mostly, I'm not, I've heard of type state pattern. I just don't remember what it is. Okay, so life system, we have this as an option box dying for the life system. Now we want to create our player with a life system. Now, if I wanted to convert game object, like right now it's starting with a none. If I wanted like to convert game object to use more of a builder pattern, and then this will give it because they all have draw systems. It's like this might be more interesting to use for a builder pattern. So what we can do for this is have a game object builder. I think we can start with a CI test for use builder to create game object. So that it can be like a very generic game object to begin with, like which the basic one, I suppose. So one without it would have to be without a CI if we want to build like a player through the game object. So you test use builder. So test use builder to create game object to create player game object. So let player, which is going to be a type of game object, is going to be equal to game object builder new like that. And then we're going to just start building this out here. So we need a game object builder. All right, so that makes this test happy. No? Mismatch types, expected struct. Oh, game object. Right, so we're not ready yet. Okay, so then dot build, and then that probably should fail, right? So we really want you to be a result that has like an error in the case that it's failing. Because for our game object, we're going to we absolutely have to have a location. We have to have a draw system. We don't have to have a physics system. We have to have a width and a height. And we don't have to have a life system. So if we do location, we reorder this a little bit. Do all the pub stuff up top and then alphabetical order. So if we do location first, if we want this to be successful, we need to unwrap this. Okay, so then off of here on game object builder, we're gonna do the location, and then pass it in an X and a Y. So if I do something like 50.0, 50.0, so it's actually that width equals 0. Wait, this is location. X 50.0, Y, let's do that. Let's do 55.0. X and Y. Okay, so then location, we're now going to implement that adds in the location. So game object builder will have a location that will be a option point to F32. So new is like that, but now we're going to have a pub function location takes in a mutable self. Oh, and okay, I see what you're meaning. That we could have this. This doesn't have to be an option. We could have this just be a point to F32, and our location could be a point to new, like 0.0, 0.0. So we start with that. Then in here, we have a mute self and we have a new location. We're going to return a self. And so this would be then self.location equals location, return self. You kind of need to be given, you are, point to F32. Okay. So then in here, location, you need to be a point to that we hand it. So point to new X and Y. Okay. You also need to be a game object. So we're like slowly moving towards this. Then what's next? We have a location. We need a width now. So dot width. If we give you that width equals 100.0, we're going to pass in the width. So we're going to make you happy. So have a width. We can have you be F32. We'll start you off with 0.0, and then we'll have a pub function width. Okay. So now we have width set up for us. Great. Still missing that build that creates that creates the full game object, and that's because we're still missing some stuff. So then we need a draw system. So you will have a draw system is a none here. Okay, so a draw system is going to be optional. So wait, no, is that true? Right now, what do we have draw system wise? Where's my draw systems? Why can't I? Oh, there you are. all we have is the player draw system. But what I'm thinking of doing is we'll have like a generic draw system that just, well, I don't know if I can do that. So you'll have to be an option none because I don't know if I can do an option, something for that. So draw system is an option with a box dine draw system. So draw system, you'll be a none to begin with, and then we'll add you in. Okay, so we'll have to create a new draw system and then add you that in here. So dot draw system. This will be a sum. No, it doesn't take an option here. This one has to take in something like some draw system, but it's gonna probably have to be a box new player draw system new, and then you take in a config. So having like the player draw system be some kind of builder pattern would also be really nice here, because then I could pass this in properly. So player draw system new, yeah, like I'm realizing that passing the config in deeply into the application or into the game and then having everything just sort of grab from the config directly, I think that's a mistake. I think having like the top level grab from the config and then pass the values from there would be best. I mean, it's not like not like this is Bevy where I can just change the config and everything magically updates live. Because I haven't set that up for ourselves behind the scenes. So this unfortunately means I need to see player draw system new. We need to pass in the config. So I'll just pretend I have it right now. And draw system, you return a oh, you turn to self, so that works. But that does mean I need a config. Okay, so then we're going to implement draw system. And you're going to be a box with a dine draw system in it. We're going to turn a self. You're not a mutable reference to self. You're actually taking ownership and then returning a brand new self. So then we're going to do self dot draw system equals a sum draw system. And returning self. Okay, so that's happy now. We now have our draw system. Okay, then next up is our life system. So we're going to do the exact same thing here. Except this one's going to be optional. So now we're creating a player game object. So this one we're going to create this in. So life. Life system, new box, new player life system, new, and then with however many lives that we want. So 3 lives, and we'll pass that in here. Okay. Live system? What do I call it? Life system, like spelled correctly. System, you're a box, design, life system, return a self. Okay, so self dot life system. Well, we need to store you too. It's gonna be an option box design life system. Okay, so self.life system equals sum life system. And return self. Okay. And back to the top. Then our physics system, which again is another option because not everything is going to have physics. Some things will, but other things do not. So then physics system box new player physics system new, and you also take in a reference to the config. And what do you return? You just return new. Okay, so perfect. So you're also an option box design physics system. System, okay. And you need to be a sum. System, okay. And then we'll return sum. Okay, so then that's all happy. And then finally down here, okay, so we're done with building the game builder. So which means that we can now run build, unwrap this because it will be a result that gives us a player. So we'll have a pub function build. This brings in a self, ownership of self, returns a game object. All right, so now we get to actually do this. So, and it's not game object, it returns a result. Now I could just do like a game error, but I think we should like create our own error for this. So a result for the good, it's going to be the game object. And for the error, because it is right, it is okay and then error, yeah. Now you were suggesting, I think Peyton, you were suggesting, oh, this error crate. Let's go take a look at this error. provides a convenient derive macro for the standard library's standard error trait. Oh, so okay. Derive error and debug, and we can have an enum for that error. So this could be maybe like, what do we want to call these? We need to create our own errors then. That would probably be in the main source. We would end up creating like an errors .rs. I mean, library, we're going to source that. Okay, so this would be a pub enum. We'll call these jungle errors. Those sound fun, right? Now, is it best to keep the errors like centralized like that? Or should I have like a specific error for each like a game object error? I don't know. So let's see. Maybe I should have like a specific game object error, and then that would go into the same file. That actually might make more sense. Okay, I won't create this file yet. Don't need that yet. And I mean library, we don't need you. We'll go back to game objects, and we're going to create errors for this specifically. So at the top, so here's our traits. Let's do this here. So this is going to be pub enum game object errors. And I guess it probably should be game object error singular because it'll only be one of each. And so this could be and would this be a game object builder error? In which case it should go right by the builder. Game object builder error. I want to derive error and debug for this. I can't derive error. Because we need to pull in this crate, which we can do with a cargo add. It's just this error. Okay, so then pull in you from. Oh, you don't know how to pull that. Oh, right, I need to reload the workspace. Come on. Finish indexing. Huh, there's no pull in. Fine. Okay, if I do... Oh, okay, hold on. It's this error, error. This error, error. Okay, wrong number of type arguments found, expected 2, found 1. Okay, so back to this again. Our error now is going to be a game object builder error. And now it's just saying, hey, we should actually return that. Okay, so now that we have that set up, we can now, for right now, let's just blindly create this, and then we can test our errors in a little bit. So we're going to return an okay. Whoa, nope. Game object new. And in fact, we don't even need the new. It'll just be a game object like this. Oh, I was hoping it would like start setting this up. So we need a location, width, draw system, life system. So we need these. So we won't have hub. Our colons will be fine. So for location, that'll be then self.location. Giving ownership is fine for this too, because it's about to go out of scope. For width, it's going to be self.width. Because each of those are the right types. For our draw system, it's going to have to be a... Well, already this is correct. The draw system... Oh, no, we have to make this a... extract that out. So... unwrap. Wait, hold on. Draw system. That's an option, though. And we need to like get out of this value. So we can unwrap this for right this second. We'll be able to do that earlier and handle that as an error. For a life system, that can just be self.life system. And for our physics system, self.physics system. Since those are both options, that'll be happy. So that gives us this right here. So if this entire thing works, we're happy. And we don't need this to, this can be a CI test because we're not generating a, what is it called? A context. So this should run so far. Yes, it does. Okay. Then I want to assert equal like some of these things that they actually got the items that we cared about. So assert equal. Let's do our width first. So actually location. So what is it going to be? Player dot location dot x is x. Insert equal. Player dot location dot y is y. Insert equal. Player dot width is width. Then it gets a little bit more interesting with our draw system. I don't know if there's a good way for me to like test that exists. The live system, we can check the lives. So we can do assert equal player dot life. That's an option still. We could do player dot life system dot unwrap dot lives is equal to lives. And physics system, I don't even know how to. Oh, you know what? We could just unwrap it. If it unwraps properly, so this would be assert that unwrap doesn't cause a crash. We don't even need this to be that. We could just unwrap it here. If that doesn't cause a crash, we're good to go. So player life system and then player dot physics system dot unwrap. And that's it. So test again. How am I getting errors there, but no errors here? Right, strict comparison. So we want to add in this this fun. So what is it? Clippy. No, it's allow Clippy float compare. And then you're happy. Okay, perfect. So with that all done and set up, we can now create our player in our map, hand it the life system, and it'll get the life system properly. Okay, so we've got that. Now we want to like actually use that life system when we draw. Because our draw system needs the life system in order to properly. Our draw system needs the life system in order to draw out that heart and like place the heart where it's supposed to be. So we have the image, we have all that stuff. Let's go ahead and in the main scene, we have our player here. Let's use our new builder and sort of like recreate the player, as it were. This is going to be a game object builder. Now this is going to be interesting because I'm returning a game result, not a game result builder result thingy. So that's going to be fun. I may have to convert that over. Not sure exactly how I want to handle that yet. We're going to find out really quickly. So new, and then in order to like build, we have to okay, so what do we need? We need our location. So dot location. Now here we're passing in, okay, like the config player, this needs to be a point two. Yeah, point two, new, config dot player start, starting X, player starting Y. Okay. We have the width. with the config dot player width. We have the draw system. So draw system, and this takes in a box. So box new. This is going to be a player draw system new reference and the config. Okay. Then a life system with a. Okay, this is new for us. This is going to be a player life system, new, and then the lives is going to be config dot player lives, and then the physics system, which is going to be a box new player physics system new config, and then dot build. Now I can't question mark this because they're incompatible types. Also, you expected struct box Stein found struct player life system. You need to be a box new. Okay, we're happy there. Now this question mark unfortunately isn't compatible with this. So we could do an if let and then return a game object that's created, and then return a game error. If it's not really the right. Can I find game error? Not really. It doesn't know where to find these. You can maybe go to game results. Okay, so here's a game error. Here's like the game error that GGEZ provides for me. And I don't really get like I don't really have much to go with here. I might need to right now just panic, because I can't, like, I can pass in this game error, but none of them like make sense. So we can match off of this. If we get an okay, we get the game object, and we return the game object. If we get error, we get this specific game object builder error. And we probably want to, like, we can't not create the player. We need to, like, just we're done. Like we're yeah, everything is gone. Everything's terrible. We could just panic and then pass in. Can I pass in the error? Oh, apparently I can. So if I, well, I don't even have, I haven't implemented any of the error stuff. This is never going to happen right now. Even if, like, it'll be a completely different error that panics out from the type system. But okay. So we did this. We have our player. We can get rid of you now. And then we pass that in here. And that gives us a life system. Now we can take this life system and pass that into the graphics, the graphics draw system. So the draw system. So the player draw system, when we draw, we need to know the number of lives left. And that's going to be in here. We're going to have, probably we could just pass in lives left here. So lives left. And you can be a U8. We don't need to like pass in the full life system. We just need the lives left. Now, is that true? Because this is the trait draw system for everything. So it really needs to be, we do need to do a life. We do need to pass in the life system as an option. As an option. And I think this would be like a reference to the actual life system. I think that's how I would want to do that. You wouldn't be that. You would be a box with a dyne life system, like that. Wonder if I can get away with that, or if I need to have that be a reference. Okay, so if we do this, now you need to be updated to pass in life system is a option box dyne life system. Okay, so you're helpful here. And then down here we have a test that is passing in drawing this. So draw, we'll just pass in a none for you. And for you, okay, so then in our mod, we have our life system here. And it's already an option. So, and with a box dyne. So we could draw with the self dot life system. Oh, because you're passing in a physics state. That's why. It's probably cloning it. So we cannot move out of here. Can I give you a reference? And if I give you a reference, that would be a reference here. I don't know if that makes sense. Essentially a reference to a none. Well, it's not airing out, so we have that. And so then we have the image. We just want to draw the image based upon the number of lives that we have left. So implement draw, have a game result. We have a bunch of these draws. We're drawing all these rectangles around, which we don't really care about right now. For this, we need to unwrap. Okay, so if let sum life system equals self, not self, life system. Okay, so now we have our life system. We want to get lives out of it. we can't just get lives out of it. We have to have like a get lives method. So we're going to have a function get lives, which takes in reference to self, and it returns a U8. Player life system. Returns self.lives. Okay, so happy for you. Player draw system. Now, we're gonna loop through all of our player lives. Let's maybe start with like, we'll just do one for right now. Just do we need to get the heart image, don't we? So we need to extract that out. We have that through images. That's already being passed in. So we should be fine here. Let's just draw it out. We'll just do a graphics draw context, a reference to images dot life, and then draw the RAM new dot destination. Well, we need to know where to draw these. That's going to be an interesting thing. If I don't give it a destination, it should be the top left side, I think. And we'll just do that. You need to be in here. So let's end up seeing what this heart looks like on the screen. That is huge. Okay, it's a little bit bigger than we needed. Just a teensy tiny bit bigger, but it shouldn't matter because when I get it the new size, we can extract the size of this image out at runtime. So we want this over on the right hand side, so we can get the size of the image, the width and the height of the image. The height probably doesn't matter because like we can see the Y is fine. It's the X. So we need the width of the entire screen, which I think we have through our config. So we need the width of each of the life system, each of the hearts. So let width equals images dot life dot width. Gives us a U16. It's less helpful, so let's convert that to an F32 right away. Once we have that, we also have our config object. That will give us everything we need. So now I want to draw this on the right-hand side. So we're going to do a dot dest. For the X position, it's going to be config dot resolution X minus our width, and then 0.0 for our height, so just as tall as possible. So just with that change, now our heart is on the right-hand side of the screen. Okay, perfect. Now if I want multiple hearts, we're going to get the number of lives, and we have to loop through for each of these lives draw a new one with increasingly farther to the left. So we'll do a for loop. I guess like this will be just a count in 0 ... life system dot lives. Bring you up in here, and then our resolution x minus width minus count times I guess the width. It's a little bit confusing. Also count, okay, you need to be as F32 as well. Oh, fine, you won't let me do that there. Do that here then. Oh, it's count. Sorry, excuse me. The width is fine. Count is as F32. Okay, does that give us 3 hearts? It does. 3 hearts right there. I could go into our config and we can change this to we start with 7 hearts. And we start there with 7 hearts. We can move to the other screens and it just stays on screen. Okay, perfect. And then the final thing they want to do is resize that down a little bit. Let's come back to Sprite and let's re-export you. And instead of 1000%, let's do like 200%. Can I export you to a different location? Oh, I can. I can export you directly to where I want you to go. So, documents, code, builds, jungle, resources. You become heart.png. And look at that. Beautiful small hearts that look appropriate. And I can change their, I can change which file that we're going to use for it at any time. And we just have to update the config. And then we can play with the hearts in here. And that will allow us to then fall down in here. We can fall down the pit. And then we'll lose 1 or multiple hearts. And then we'll be in the caves. So that's fun. Cool. Let's go ahead and quit out of here. And let's clean up some of this. We only have 1 warning. Oh, new function is never used anymore for game object. All right. We can just completely get rid of this now that we're using the builder. Clean that up just a little bit. Oh, so now our tests, though, need to use the game builder, the builder for this. Well, and then this is, we don't need these tests that like just to create the builder object because we have the game object builder test to build that. So this test isn't needed. Drawing is like, I don't think we need like a draw test either. Because like, it's just, does the function work or not? Like, the type system should help with that. Test update game object. I don't think we need any of these tests, do we? This is okay. Use builder to create game object. That's our most important test here. So save you. You're happy. We don't need you anymore. Now, each of those individual like draw system, they could have their own tests or own systems to run. The game object doesn't have to care about those. And so we deleted a bunch of code, we added a bunch of new code, and everything works. No errors, and we actually did the thing. So we finished. We did 2 pull requests today, or we're going to do 2 pull requests. Go ahead and close all of you. Okay, so we're in the right branch. All right, so we are displaying lives on screen now. I'll push you up, and we'll also do a pull request over to main. Okay, so part of display lives on screen, created a life system for the player game object to track their lives. And that'll be nicer for us when I eventually convert over and start putting like trees and everything else into the game objects. Which right now they're not, but I want to like go in that direction. Okay, so what are you? You are number 52. Wait a second. You're not 52. You're the wrong repo. We're in jungle. You are number 24. That makes more sense. Oh, I guess number 19. Oh, this is issue 24. Okay, got it. Pull request 24, issue 19. And basically all I have to do is wait until all of these tests pass. Once they do, then let's see. The pull request one is the one we're really caring about. They should pass. All the tests were passing locally for us. And then we'll all be good to go. And so with that, I think it's 11:50, which is time for me to go make lunch also as well. And perfect timing. We got 2 things done. So with that, I'm gonna stream marker in.